Hello, I'm here today to explain to you quiz number 3. I must apologize for the delay in releasing the quiz explanations. Week 5, week 6 is really crazy, and I imagine it must be crazy for you too, right? I actually tried to record my explanation last week, spent about 45 minutes recording it, but then I think I was too tired, so the recording was really bad. It's really bad lah. So I decided I need to record this again. Now let me just say a couple of things. I'm going to experiment with this video using the iPad and the Apple Pencil. I hope it makes my life easier, because if you watch the explanation for quiz 1 and 2, I did it on the whiteboard. So every time I made a mistake, I have to erase everything on the whiteboard and write again. And iPad is supposedly digital, so it should be better, right? Well, who knows? Let's figure it out. Okay, so section 1, we have a set of 3 conditionals, right? If monkey, if panda, if elephant, right? Now, when you're reading an algorithm, you're supposed to read it sequentially. Read it line by line, one after the other. You're not supposed to skip anything. You're not supposed to go backwards unless there is an explicit command, an explicit instruction to do so, right? So what would that explicit command look like? Conditionals, right? If A, then do this, else. So that means not A, do something else, right? You skip a few lines of code and jump straight to do the stuff that's in the else portion. Or how about going backwards, repeating a set of instructions? That's when you need the explicit command of a loop. All right, so let me visually illustrate to you the algorithm for section 1. All right, so the first conditional, we have 3 conditionals, right? The first conditional set is if monkey, yes. If yes, what do you do? Peanut butter. Okay, now what do we do if it's a no? Well, notice that we actually had no instruction, right? So you do nothing. Then the next one is if panda. Then what do you do? Then you shout rainbow. And again, what do you do if there's no panda? Then you do absolutely nothing. And then the last one is elephant. If elephant, then if there is an elephant, what do you shout? You shout swimming trunks. And if there's no elephant, what do you do? Then you will proceed to the next part, nested conditional, right? In this case, we need to check for mouse, okay? And if there is, then you shout tuna, sashimi. And if there's no mouse, then what do you shout? You shout cheddar cheese. And last but not least, all this terminates, right? Because we have reached the end. What does the end if do? I actually covered this in the lecture videos. End if is just to tell you that you have reached the end of the first if conditional. So in this case, this end if is for this if, right? This end if is for this if, right? And then this end if is for this set over here, and this end if is for this set over here. Why do we do this? Because when your algorithms get more and more complicated, what's going to happen? You're going to realize that it's very hard to tell which instruction belongs to a certain if command, right? It belongs to a certain conditional, right? So we use this, and we use the indentations to make it clearer. So now, how do we visualize the flow? How do we read the algorithm? Okay, now let's imagine that you see a panda, right? And you see a wombat. Haha, cute, right? Panda and wombat. Now, some of you ask, do I put the panda into the algorithm first and then I put the wombat? No. If you do that, that's a loop, right? So in this case, we are just saying, you see these two cute animals? Do you see these two? If you see, and then you do accordingly. So what are we going to do? Okay, so remember, we have panda and wombat. Wombat. Sorry, my wife and I call this wombat because it's very cute. Okay, anyway, so what do we do? Okay, let's look at the algorithm, alright? Do you see a monkey? No monkey at all. Okay, so in which case, we will do absolutely nothing. Okay, then the next conditional asks, is there a panda? Yes, there is a panda. Hi. Okay, so what do? We go down the panda path and we shout rainbow. Alright, now the next one we ask is the third conditional. If elephant is basically asking, is there an elephant? No elephant. Yeah, so no elephant. Then what do? You go down the path that says no, which is the else. You do everything here. Alright, so you go down this way. And notice what we need to check now. Is there a mouse? No. Okay, this one is as small as a mouse, but this is not a mouse. This is a panda. This is a wombat, right? So no mouse means you go down the no path and you shout cheddar cheese. And then the end. Ta-da! Okay. Now, shall we try this again? Okay. Yeah, let's try it. Okay. I think just to clarify some doubts that you might have. Okay. Let's say, for example, I now have a whale. Novel. My wife sold this for me. Okay, so let's go through the algorithm. Okay. If monkey, any monkey? Nope. Okay, so you go down the no. Any panda? Nope. So you go down the no. Any elephant? Nope. So you go down the no. Any mouse? Nope. So you go down and you shout cheddar cheese. The end. Alright. Now, next question. What happens if you see an elephant? I drew this because I don't have an elephant. Okay, so what happens if you see an elephant and you see a mouse? I also don't have a mouse after all, okay? So what happens if you see an elephant and a mouse, right? So we first things first, if monkey, no monkey, right? Then if panda, no panda. Then if elephant, yes, got elephant, right? So then we go this way and we shout swimming trunks. Some of you might want to ask, what about the mouse? Squeak, squeak, right? Notice what happened. You went down the elephant path, right? So according to the instruction, you only do this part here. I know in the else portion, we got checked for mouse, but we did not go down that path. The control structure, the conditional, did not tell you to check for mouse. So all you have to do is just shout swimming trunks. That's it. Okay? End of story. I hope that helps to explain section 1. Okay, let's move on to section 2. Section 2 is another stupid one. Okay, so section 2, what do we do? Again, we ask if cow, okay, yes, then you shout moo. No, then you shout hamburger. Okay, then we go on to the next conditional where you shout chicken. Where you ask whether there's a chicken. If there is, then you shout pok, pok, pok. Okay, and if there isn't, then you shout tasty. And then you end. Okay, now what happens if you have a cow? If you have a cow, then you, of course, you go shout the moo. Okay, you only have a cow, right? So you go to the next conditional. If chicken, remember we only have a cow, so what happens? No chicken, we do what is in the else portion of the chicken conditional and we shout tasty. So what do you shout? Moo and tasty. So similarly, if you have a chicken but no cow, okay, no cow, then you go this way, you shout hamburger, you got chicken, then you shout pop 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 and then end. Okay, that's the end of section 2. Now let's talk about section 3. Alright, now section 3, some of you are very confused. Okay, so we can do the same thing. What I wanted you to do was to be able to identify the flaws in the algorithm. So I gave you some scenarios so that you can identify whether some scenarios will work or whether some scenarios will not work, right? So here's the bread version of the story. Again, we can draw up the diagram, right? No rain. Okay, if yes, then what do? Lay picnic mat, and then the next thing we do is very sunny. If yes, then what do? You open umbrella, Ella, A, and then you offer some block. And then we have another one, bitten by mosquito. Yes, then you offer mopiko. For those of you who are not familiar with Singapore culture, mopiko is this cream that you rub on your skin if you get bitten by a mosquito. Okay, anyway, so if you're bitten by mosquito, then you offer mopiko. No, then you USB fan, right? And then what do we have? Okay. Notice what we have here. If weather is very sunny, then we will do all these things. Notice this. eat food on picnic mat, that is under the else portion. So in which case, we will write it like this. No, then eat food on picnic mat. What about this line here? Else open umbrella. You see this else? Alright. So we know that we have this end if here, right? And it all works for this part. And then we have this end if, and we know that it's for this part. So this else and this end if, notice the indentation, right? So it belongs to the if not raining portion. So what's going to happen is that we will only open the umbrella if it is raining, which is here, open umbrella. Okay, in which case all of this, okay, will all terminate and end like this. All right. Okay, so if it rains, all Brad will do is just open an umbrella, nothing else, right? If it doesn't rain, at least you lay out the picnic mat. If it's not sunny, then you just eat the food. Notice what happens. If it doesn't rain and it is not very sunny, that's what I mean by weather very fine. Weather very fine, weather very nice means no rain, not very sunny. Then what happens? Notice all this stuff here, they're not done at all, right? Okay. So I hope this gives you a better understanding of how to read the algorithm. Okay, here's the Eddie version. I think by now I don't need to draw the illustration for you, but I think you kind of get the picture already, right? Okay, so now let me explain section 4. Here's 2 common ways that people like to define loneliness. The question is like, how do you know if somebody is lonely, right? Some people say, oh, you know the grandma is lonely if grandma always go out, always talk to a lot of people. Maybe you might encounter people like that on the bus, train, or coffee shop, right? If somebody always go out and talk to a lot of people, are they necessarily lonely? Not really, right? Some people just very talkative, right? Now, version 2 of the question is another definition of loneliness lah. Some people think that if you always stay at home and you always don't talk to a lot and you don't talk to a lot of people, then you must be lonely. Again, is it true necessarily? Introverts, I'm an introvert. I like to hide and avoid social interaction. I'm very happy being alone lah, right? Am I lonely? Nope, not at all, right? So the issue is it necessary? Yeah, if you want to make sure your modeling, your detection models, your decision models are good, it's always important to define it using the necessary conditions. Otherwise, you will have a lot of people who will just slip through the cracks. Yeah, so none of these conditions are necessary. Now, contingent is a technical term which I explained in the lecture videos. Is contingent, simply put, it just means not necessary. Okay, I have this example, milk tea, right? Necessarily must have milk and must have tea. What is contingent? The brand of the milk. Or some people say, oh, I don't like fresh milk. Fresh milk is bad for me. I want to drink almond milk. You put almond milk and tea, what do you get? Rubbish, because almond milk tastes like cardboard juice. Yeah, so it is not milk tea. Yeah. Okay, talking rubbish. No, but so what is contingent? The brand of the milk, the brand of the tea. Yeah, necessarily you just need to have tea and milk. That's it, right? Is it sufficient? Yes, it's sufficient, but it is not sufficient for bubble tea, right? So bubble tea. I'm lacking one more condition. Must have bubble pearls lah. Must have pearls. So must have milk, must have tea, must have pearls. Bubble tea. Must have sugar? No, sugar is contingent. Yeah, not necessary lah. Yeah. Okay, so I think I've explained section 4 sufficiently. I hope. Yeah. Okay, so let's move on to section 5. Section 5, I give the example because some people think that, oh, the more scientific things get, then it's not a proxy measure anymore. But think about it, Here I'm talking about cortisol levels. Cortisol is not a lonely hormone. Cortisol is a stress hormone, right? So in which case, just because you have high cortisol levels doesn't mean you are lonely, right? It's a stress hormone, right? So there are many other reasons, many other confounders, right? For that can cause the cortisol levels in your blood to spike. Yeah, loneliness is just one of them. So it's not a direct measure. It is still a proxy measure. Sometimes it works, sometimes it doesn't work. If you want to use cortisol level to measure loneliness, then it has to be restricted in scoped down very narrowly in very specific situations where you can be very sure that an increase in cortisol necessarily relates to loneliness. But what kind of environment do you scope it down to? Then that one we have to figure it out ourselves. Okay, now let's do the last question, the section number 6. Now this algorithm, this system, I say in the question that this is actually a real system. I don't want to name the company. It's a Singapore company. They've made a very stupid device. I install motion sensors all over the house. If grandma doesn't move for 5 minutes, a stupid system will go off. It's not just that the system is stupid. I mean, imagine if you are grandma, grandpa, your children, grandchildren install this system for you. It's not just that it's annoying that you cannot stone and sit still for 5 minutes. You can't like do meditation or mindfulness or whatever. But the fact that every time you stone long enough, the alarm will go off after 5 minutes. I mean, yeah, you wave to stop the alarm, but every time the alarm goes off, every time it goes beep 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 beep, it's a very morbid reminder of your mortality, that one day soon you will die. One day soon you will not be able to wave your hand to stop that beep. Very morbid, huh? Yeah. But that's the problem, you see, when we're so busy solving problems, fixing things, fighting fire, it's very hard for us to take a step back and just pause and reflect and think critically about what we're doing. So so we can't really blame them. It happens even to the best of us, all right? So this is why I'm teaching computational reasoning to you, so that we can really pause and think about the things that we're doing. Are we, just because we get an answer, just because we get something that works, does it really work? Does it work well? Or is it like just messing with us, like Lou minus it's just messing with all of us, right? Yeah, okay, anyway, so I don't know what more to say. I think by now you should already know, now that you know how to visualize and read the algorithm from the earlier demonstrations, I think you should know what is done and what is not done, right? So just for clarity's sake, okay, let me just highlight this. So this is a nested conditional. This is another nested conditional, right? So we got the green nested in the purple, nested in the top level conditional, yeah? Now, notice, let me just draw your attention to this. Notice the else here. Else update status, grandma is sleeping. This happens if this condition is not true. If current time is not grandma's sleeping time and grandma is at home. Notice, you need to satisfy two conditions. Grandma must be sleeping, grandma must be at home. If these two are true, then you will do everything in here. If any of these two are false, then you will be doing this. So that means if grandma is out of the house, the system will tell you that grandma is sleeping. Or should be sleeping out of the house lah. Or not, she could be going market, right? And here's the scary thing. So the system is limited in its detection abilities, right? It will only check if it is outside grandma's predefined sleeping time. So anything that happens during grandma's predefined sleeping time, the system will just give you the false sense of security and tell you that grandma is sleeping. Not good, right? Of course, not easy lah. How do you have a system that detects these things well, right? So basically, if it's not grandma's sleeping time and she's at home, then you will check if grandma didn't move for more than 5 minutes. If so, then you will update the status here, turn on the alarm, and if she doesn't wave her hands or whatever, then you will alert everybody. If she does, then you say okay lah, all is good, grandma is fine, yeah. And then yeah, that's pretty much it lah. Is this a good system? Again, necessary. We need to check for necessary, sufficient, and contingent factors. What do you think? Yeah, this question was here to provoke your thoughts about the kinds of systems people are developing lah. Yeah. All right, okay, I think that's all. So thank you very much for watching, and I'll see you again soon. So bye bye.